Not yet.
Okay,
Yeah,
thank you.
yeah, it's come.
Okay. Okay, so now you can see here, I can again explain what I can do in here. So first of all, you can see, I just simply import my image collection, Sentinel multispectral instrument, surface reflectance image of the Sentinel, and I simply import my Dhaka City new shape file in here. Okay, Dhaka City new shape file imported in here. In this time, I just observe what is the condition of the NDWI or normalized difference water index for the two seasons, dry season and wet season. Okay, so I just simply call my image collection Sentinel-2. I simply use the filter bounds function. In this time, filter bounds function is mainly intersecting with your whole collection with your region of interest. Then I simply put here the time period. I select the time period for year of 2021, dry season time period. Okay, and then I simply filter image properties. I select the cloud pixel percentage less than 1%. Here I find out total 72 images. All of the images I create the median composite. Okay, then click with my shapefile. I can get this satellite images. You can see for the dry season image. Dry season image, there is a no cloud, and it's very clear satellite image we can get for the dry season. The same process I also do for the wet season image. I simply call my image collection Sentinel-2, then filter bounds with the ROI, then filter date. I simply put here the time period for the wet season. Okay, and after this, I can simply make this composite for the wet season. In this time, you can see wet season image or rainy season image. Here I find out some cloud. Okay, so this type of cloud. But we can easily remove all of the cloud and haze from the satellite images and get the very clear satellite images. So we can easily remove. So I also try to show you this part for our next class, how you can easily remove the cloud from the Sentinel-2 satellite imagery. I also try to show you this. Then you can easily apply this code for any region and can get the remove the cloud and get the very clear condition of the satellite images. Okay. In this time, I use the both of satellite images and then try to identify what is the condition of water on the surface of Dhaka city, ground surface water. Okay, for the dry season and wet season. In this time, I used here the NDWI or normalized difference water index. So normalized difference water index formula is that green band minus near infrared band divided by green plus near infrared band. In this time, this equation I just apply for the dry season image and wet season image. There's a lot of method for applying this equation. I also try to show you all of the method. This is the easiest method, is that normalized difference. This is the built-in function in Google Earth Engine platform, normalized difference. Mainly this function is calculated this type of equation. Okay, if you want to check the more details about the information about this, simply copy and then paste in the docs tab. I simply paste. You can see what is the function. Mainly this function compute the normalized difference between two bands. When you want to calculate any indices between the two bands, you can easily use this function, any two bands. Okay, and it computed as a first minus second divided by first plus second. Okay, in this time I just calculated the green minus near infrared divided by green plus near infrared. Okay, in this time I simply make a list in here. Okay, in this list I just put here my band name. So my band name is that green and near infrared band, not green and near infrared band. I also mention the band name. This is the band description, green and near infrared band. You can get the band name from here. You can check the band name also. I simply click on the band name. You can see green is the description. Okay, and what is the band name for the green? B3. Okay, and red is the description. What is the band name? B4. I need to work with the B3 and B4. Okay, so just I simply put here the B3 and B4. I make a list in here. Okay, I simply use here the parenthesis and make a, so B3 and simply put here the B4. Okay, green and near infrared band. Okay, so this two type of band I simply select. You can see I check again. B3 is the green. Oh, sorry, near infrared band is the red band. I need the near infrared band. So what is the near infrared band? You can see B8. Okay, near infrared band is the B8. Okay, so I simply use here the B8. Okay, sorry for that. It will be B8 because I need the green and near infrared band. I simply select this. So in this time, you can see what happened. Dry image. I simply call the dry image. This image. Okay. This is the dry image, dry season image. I simply call the dry image and use the normalized difference between the two band, green and near infrared band. Okay. Same process I apply also for the wet season image. Just I simply copy the variable name. Simply copy the variable name and paste here. Okay. In this time, you can see I just simply call the wet season image. Wet season image is already stored in a variable. I simply copy and then paste here. Okay. So now you can see I will send the name. Suppose this is the NWI. Okay. You can see two type of. In this time, I calculated the dry season NWI and wet season NWI. In this time, I am to show the map on my map interactive view. So just I simply use here this equation such as map dot add layer, and then I simply call the NDWI dry. This variable I simply call. Then use here the run. Okay. Now you can see another layer also added for the NDWI dry, but I did not add any visualization. That's why first time I can get totally black and white color map. You can see the same process you can also apply. Suppose map dot add layer and call the NWI wet season image. Okay, so I can get this type of image. You can see wet season and dry season image NWI I can get, but I did not identify where the water high density, where the water low density. I did not understand because I did not add any visualization. So in this time, I just simply add here the visualization and then check. If you want, you can also export this map. Suppose in this time, I simply export the map for the NWI dry season and NWI wet season and easily make this map using the ArcMap software. Okay, for making this map. So I also try to show you this part, how you can easily do this. So then you can easily understand. So in this time, it's showing the raw value. Okay. In this time, I did not show you all. I did not use here the visualization. Without the visualization, this may look like this. So in this time, I add here the visualization. So I simply create a visualization. Suppose I simply take a variable. Suppose okay, I simply make the dictionary in here. Without I simply make the dictionary and put here. Suppose I want to show the mean pixel value. It will be start from the -1 and max up to 0.5. This is my range. And I also make the color list. Suppose I simply use the related function and make a color list. So in this time, you can use here the any color. So I want to show mainly what is the NDWI. NDWI, this is the negative pixel value is identify there is the no water. Okay, but positive value, high positive value is identify there is the water. So in this time, I just apply this method and try to add here the visualization. Suppose I want to show which pixel value is the negative or close to the negative, it's showing as a red color. There is a no water. Then greater than the red color pixel value, I want to show such as suppose yellow color. Greater than yellow color, I want to show such as suppose green color, and greater than green color, I want to show as a suppose blue color. Okay, and we add this color plated. In this time, I want to also add here the layer name. Suppose this layer name is that NDWI right. Okay, and also do for the same code. I simply copy the same code from here. I simply copy and paste the second line. Just paste. Okay, and I simply put this. Suppose this is the NWI. Wait, okay, then done. In this time, I simply click to the run. You can see now you can get the visualization also, and you can easily change any color. Okay, it doesn't any method, and you can easily download this TP images and work with the ArcMap software, and you can easily work with this. So in this time, I can get this image look like this. So you can compare the two images for the wet and dry season. So here I can get the total 4 layer. You can see dry image, wet image, NDWI dry, NDWI wet. Okay. So now I can check. Okay, so first map you can see now it's showing the NDWI for the wet season. So and second you can see dry season. So you can see wet season, mainly wet season, you can identify the lot of water body. You can see lot of water surface, lot of water body in here you can see. And the dry image you can see very little, only for this lake, only for some water body in here. But when I open the wet season image, wet season NDWI, you can see we can get this a lot of water body also appeared for the wet season. Okay, you can see. So now you can easily download these TP images from here. The same process we can apply. Just suppose I want to download the TP images. Suppose I just simply use here the function export image to drive, and put all of the argument one by one. I just simply make a dictionary, curly bracket start and curly bracket in. Okay. Then I simply use here the image, and then I simply suppose I want to, you can see I want to download the NDWI wet image. Okay, NDWI wet image is stored in a variable. What is the variable name? NDWI wet. Okay, I simply copy and paste here. I simply paste here. Then description, it can be anything. I can simply put the name, suppose NDWI wet season, anything. And folder, you can put any folder name. I simply put the folder such as you can put any name. File name is not needed, dimension not needed, region. Region is that I simply put the region is our variable name, ROI. Okay. Then scale is the resolution. In this time I can check the band resolution for the green and near infrared band. You can simply check it from this image information. You can see meter. Also you can see the near infrared band is 10 meters. So my resolution is a 10 meter. So just I simply put here this scale is that 10 meter, 10 meter, 10 meter. CL is not needed. I also know all the things. In this time it's not needed. Okay. Then I just simply click to the run. You can see our task will be running. And task will be running. And when I click on here, NWI wet season image, simply click on this here. Now it will be downloaded and store it in this folder G. Okay. And from this I can easily get this. Okay. So this is the process for download the TP images. Okay. In this time, the same process you can apply for calculating any indices for any two band. Suppose you need the NDVI or normalized difference vegetation index. Just you can simply put this two band for the NDVI. You want to need the any types of index, you can calculate it without equation. Such as you can see, I show you the equation EVI formula. Okay, anyone any question? You can ask me any question. Any question? Yeah, it's possible when your image is the low size. Otherwise, not possible. So less than 15 megabyte, we can download it directly. I also tried to show you this part, how you can easily download it directly, because when I want to export the shape file, we can easily download it without upload it in the Google Drive. Just I simply click to the download, it will be downloaded. We can easily download it without uploaded in the Google Drive. Okay, but it's possible when you want to work with the very small region, it's not up to the 15 megabyte. When it will be across the limit, we did not download it. Okay, so it's also some limitation. So that's why we can simply, when you want to work with the satellite image or TIFF image, we can simply download it from the Google Drive. But when you are working the shapefile, then we can easily download it from the directly. You can download it in our local device. Okay. So in this time, you can see this type of equation. You can see AVI. This is a long equation. This type of equation, how we can easily handle. I also try to show you this part. This formula, normalized difference, this function is okay. This function is okay only for the two band. Any two band you can easily put, and you can easily get the indices result. But when you can find out this type of equation, you can see 2.5 band 4 minus band 3 divided by, also you can see some constant value, also you can see some variable. This type of equation, how you can easily handle. So I also try to show you this part, how you can easily do this. Okay. So in this time, I simply go to my next slide, then check. So now we are moved to our problem solving class. So if you have any problem or any doubt, you can, now we are discussing, and then our today's class will be in. Okay, so now we are going to the problem solving class. Okay. So anyone any problem?
Question, sir. I have a question. I put in group. Sir, I want to download the Moody's Landsat for Northeast, sir. I have downloaded the Moody's user Bhuvan website, but the image is found like cloud or seen in the land use land cover, sir. I need, sir, some clear picture for.
Okay, we also covered the part when I want to work with the land use land cover classification map, because we are trying to show you all of the data set, how you can easily make the land use land cover classification map for the Moody's Landsat Sentinel. All of the things will be covered. So we covered the part. You just need to some time, okay, for completing all of that this class. Okay, so then I hope you can easily understand. And if you need the seriously needed this, I also send you my previous video recorded class, and then you can also watch this, or also send you the code link. You can also try to get the code. It also better for you, I think. Okay.
Yes, sir.
Sir, excuse me, Mr. Rahman.
Yeah, please.
Mr. Rahman, just want to have the rainfall data, Mr. Rahman.
Okay. Rainfall data set. You can see. I also try to show you the data set for the rainfall. Suppose mainly we can get the rainfall data set for the SARPS data. You can see this is the one time of the SARPS data. Mainly SARPS data can be two types, daily and panted. So two types of data set, all of the things will be same. So I simply work with the panted data set. This time interval is the 5 days interval, time interval, and we can easily access the panted data set 30 years. Okay, and this SARPS data set, we can get from the it is a combination between the satellite data as well as also combination of the station data. Okay, you can easily you can easily use the data set. It's very easy. You can also try to do for, and also make the time series chart. It also same, which I discussed in today's class. So you also try to use the data set and try to make the precipitation map as well as also make the time series chart. The same process which I show you in the NDVI, Landsat NDVI. The same process you can easily apply. Okay, I hope it's very easy. You can easily do it. Okay, and you can get all of the data set in here. Information about the data set we can
export the data into CSV.
Yeah, we can also export the CSV file from it also. So when in this time for the small region, you can make the time series chart and then click on the download CSV. It will be downloaded. But when you want to work with the big region, then you also need to export as a Excel file. I also try to show you our future classes how you can easily get the export the CSV file format or Excel file format directly and get the data set. Okay, so you can go to the step by step. I hope you can easily understand. All of the thing will be completed. So in this time, you can just use the data set and try to make the precipitation map for your region and also make the time series chart. Then face any problem, then we also try to discuss about this. When you face any problem regarding this any code, you can just send me the code link. Simply copy the code link button and copy the code then I can easily find out this problem, what's the code problem, and then solve the problem. Okay.
Okay, Mr. Rahman.
Okay. So
Excuse me,
any
sir. I have
question?
one question, sir. Sir,
Yeah, please.
I want to download any type of zip file, so we have to use this code, sir. The code are different for
Using
the
the
another
same code,
area.
same process you can easily do, no problem for this. Okay.
But sir,
Same
I
process.
have not knowledge about the code, so how to download the any type of area save file, sir.
Okay, shapefile basically some freely sources we can download it from this website, Divya GIS. We can get the some country level administrative area shapefile from this link. You can see Divya GIS org. We can get the some shapefile, all of the country boundary, administrative area, then create special data, country level data. Here you can see mainly it provides some district, sub-district, division. Okay, you can easily download it from here. Okay, from this, and you can easily import the shapefile in the Google Earth Engine platform and work with this. Okay, you can get the some all of the country boundary shapefile in here, country boundary, and also get the some administrative. Suppose I need the for the India, so just I simply select the country name of the India, and then I need to the administrative area. Administrative area, it included the total country boundary, division, subdivision, district, sub-district, all of the things. I simply click to the OK and then simply download. So now it downloaded the Indian country boundary shapefile. Okay, you can see downloaded. Then I can simply import the shapefile in our Earth Engine platform. Then we easily work with this. Okay. Okay. Any question?
Yes, sir. Thank you, sir.
Okay, village shapefile of India. So I think some shapefile is not available in GIS. So for this, we also need to digitizing using the suppose georeferenced digitizing. Okay, so suppose if you have a scanner map, you can simply scan this map and import the map in ArcMap software. Then simply digitizing. Before the digitizing, you also need to georeference. Then digitizing it, and you can easily get this shapefile. Which shapefile is not available. Okay, so it's also possible to get this with using the. It's very easiest way. You can easily do it, and a lot of tutorial is already available in YouTube or other sources. Okay. Okay. Any question?
Hi, sir. I have some question.
Yeah.
I already asked in the
Yeah,
group
please.
uh, uh, because I have some shape files of my study area. It having PRJ and other files, but it not having SHX. It having SPX. Is there any
Okay. So
solution?
okay. So what the software are you using for creating this shapefile? ArcMap.
I yes, ArcMap. By placing ArcMap, I did some like classification of LULC and like that.
Okay.
It
So
working in ArcGIS, but if I want to upload in the GE, it not having SAHX.
okay. So we need the also SSX file. Okay, so I think where you can created the shapefile, it has some problem. Okay, so SSX, this file must be need when you want to take the shapefile. Okay, and it's need because it's when you want to import, it must because the port file you must be need when you want to work with this. So if possible, you can also try to create the shapefile again, and some online source is available. Suppose different shapefile online create shapefile. You can simply search. Suppose I simply search here online shapefile. So shapefile viewer, shapefile map. My geo data. So we are also, you can see KML to shapefile. Suppose you can also need KML file. If you have, you can simply import the KML file in here, and you can easily convert this shape file also. Okay, so you can just simply try to find out the problem in your source. I think it's some problem in your source where you can create the shape file. Okay, shape file must be not .sshx. This extension must be need when you want to get the proper shape file, and also need the PRJ for projection, DVF for database. So all of the extension has a individual task. So that's why we need this all of the file. So you also try to focus on your source. I hope you can easily get the .sxx. Okay.
Okay, sir. Thank you. I will try.
If possible, you can also try to convert the KML file and then simply import the KML file in here and convert the shape file. It's also okay, no problem. Okay.
Okay.
Okay. Anyone in question?
Yes, please. Suppose we have a study area which should be analyzed using high accuracy satellite image, which should not exist in GEE. Could we upload in our asset
Yeah, we can
high
easily upload.
resolution satellite image and apply it?
Yeah,
Apply
we can easily
NDVI
apply
or
it.
whatever the question.
Yeah, anything, any analysis. Suppose when you want to work with a sport satellite image, you can simply easily import the sport satellite image. You buy the satellite image for other sources. You can easily import the satellite image in Google Earth Engine asset, and you can easily apply any types of analysis, classification, make the NDVI map, NDWI map. Easily you can do using the satellite image.
Excellent.
Yeah.
Thank you.
Yeah. So anyone any question? Okay. So today is no more. I also send you the recorded video class, so you can also just you can send me this video record in my email. Okay, so you can just record this video. You can just simply
sure.
send me, and then I also provide you all of the video. All of the people send that through your email from my YouTube channel. Then you can easily access, and also send you all of the practice code, and I will send you the some assignment. So you also try to do for yourself, and then when you see problem, we can also try to discuss our next class, inshallah. Okay. So today is no more. So have a good day or night. Okay. Okay. Bye.
Thank you.
Thank you.
Okay.
Thank you, sir.
Okay.